Hello. So in this video we'll be looking at actually how we use truth tables to evaluate arguments. In the previous video I explained that what we're looking for are counterexamples to validity. So we're looking at what we're looking for are rows where we have all the premises are true and the conclusion is false. And if a row has either a true conclusion or at least one false premise, it's not a counterexample. And once we find a counterexample, we know the argument is invalid. If we find no counterexamples on any row, then the argument is valid. So let's take a look at this argument. We have the argument P, if P then Q, if Q then R. So this is definitely a valid argument, and we want the truth table analysis to ratify that, to agree. So it's important here to understand what's going on with the truth table. Let me put this in the middle of the So there really, again, there are three parts here. There's the truth table part over here, or this is the part where so there are three sentence letters in this argument, and here's where we give them all, we look at all the different possible assignments, combinations of their different truth values. So there's the one where they're all true, and the one where they're all false, and then different combinations thereof. And we know that every situation of the infinitely many possible situations there might be falls into one of these. Is it a situation where P is true and Q is false and R is false? Is it a situation where P is false and Q and R are both true, or what? Well, it's on one of those rows. And then we ask, given that P, Q, and R have the truth value on, have the truth values on this row, what are the truth values of the premises and the conclusion? So what's the truth value of the first premise? What's the truth value of the second premise? What's the truth value of the third premise? Now, in this case, the first premise is just P, and so it gets its truth value copied from P. So it's just true all the way down and then false. The conclusion is R, and so its truth value is copied from this column. So just true, false, true, false, true, false, false. Now, this makes our job easy. Well, sorry. So now then what we need to do is look in here, in this box where we have the premises and conclusion. We need to say, is each row a row where either there's a false premise, or a true conclusion? Not a false sentence letter, but a false premise, because what we're interested in is the relationship between the premises and the conclusion. And what we want to know is, if the sentence letters have this truth value, if sentence letters have these truth values, then if the premises are true, so is the conclusion. If the sentence letters have these other truth values, then if the premises are true, is the conclusion also. So what we care about is, are all of these true, and is this false or not? And we have to look on each row, so for each combination of these. So you want to distinguish between the truth values that the sentence letters get and the truth values that the premises get. So, okay, good. So we know we're looking for counterexamples. So we want to find a situation where we have true premises. What we want to determine is, for each row, true premises and false conclusion or not. So if we look in this first column, we see true, 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 but then false, 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 false. And this tells us that on all four of these rows down here, at least one premise is false. So we already know that on these four rows are not counterexample rows, because on each of them there's at least one false premise. And so we already know that none of these aren't counterexample rows, and we're done with those rows. We don't need to fill in these question marks. We know that at least one of the premises is false. No problem. So now we only need to worry about the top four rows. Are any of them counterexample rows? Well, again, to be a counterexample row, the row has to have all true premises, but it also has to have a false conclusion. Well, here the conclusion is true, and here the conclusion is true. So this row is not a counterexample row, and this row is not a counterexample row. So we've already ruled out 6 of the rows. These rows aren't counterexample rows because there's a false premise. And these rows, the first row and the third row, are not counterexample rows because the conclusion is true. So the only rows we even need to worry about at this point are before we've done any work, are the second row and the fourth row. Is this a counterexample row, and is this a counterexample row? And they might be, given what we already know, or they might not be. But given what we know, well, true premise, false conclusion. So if those are both true, then yes, it's a counterexample row. Again, true premise, false conclusion. So if those two premises are true, then this will be a counterexample row. So what we need to do is look at these two and figure out, is it a counterexample row or not? And if either of those are false, it's not a counterexample row. If they're both true, it is a counterexample row. So let's go in here and look at premise 2. So premise 2 is a conditional, and it's a conditional with a true antecedent and a true consequent. Such a conditional is true. So, okay, if this comes out true, then we'll have true, 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 false, and we will have a counterexample row. If it comes out false, then we'll have a false premise, and so it's not a counterexample row. So we'll click here. We'll say, aha, true antecedent, false consequent. That is a false conditional. So is this a counterexample row? No, because it has a false premise. Okay, let's look at this row. So we look at first premise 2. We say, true antecedent, false consequent. That is a false conditional. Is this a counterexample row? No, it's not. Why? Because there's a false premise. So this isn't a counterexample row because true conclusion. Not a counterexample row because false premise. Not a counterexample row because true conclusion. Not a counterexample row because false premise. Not a counterexample row because false premise, false premise, false premise, false premise. So every one of these is not a counterexample row, and so the argument is tautologically valid. Hooray. So that's what we need to do. We need to look at, go through and figure out whether or not each row is or is not a counterexample row. Okay. Let's take a look at another problem. So here we have the argument R, if P then Q, if Q then R, P. So again, we can look here and we see on these 4 rows, the premise, there's a false premise. So they're not counterexample rows. And on these 2 rows, there's a true conclusion. So they're not counterexample rows. So the only possible counterexample rows are these 2 rows. So let's see, right, we have a true premise and a false conclusion. So if those both turn out true, we'll have a counterexample. And if those both turn out true, then we'll have a counterexample. So let's see, which row shall we look at first? Let's look at, let's look at this row. So, okay, if P then Q, false antecedent, true consequent, that's a true conditional. True conditional. Let's look at the second premise. If Q then R. True antecedent, true consequent, true conditional. Okay, so we have true premise, true premise, true premise, false conclusion. This then is a counterexample row because we have all the premises are true and the conclusion is false. So we want to say the argument is not valid. If we check it, it's going to say it's incomplete. We have to say which row is a counterexample row. So this is a counterexample row. So now we check it, and it's correct. So that's what you need to do. Now these 2 examples were a little bit simple in the sense that we didn't have to get into that many of these boxes to actually calculate truth values. In other cases, you'll have to, in the homework problems, you'll have to do more calculation than we did in these cases. But what these 2 examples demonstrate is what you're doing, first of all, is looking for counterexamples. If you find one, so what's a counterexample? True premises, false conclusion. If you find one, the argument is invalid. If you don't find one, after looking on all rows, the argument is valid. And you know that you don't have to determine all the truth values of all the premises and the conclusion to know necessarily whether or not the row is a counterexample or not. Once you find any true premise or true conclusion, you're done with the row. It's not a counterexample row. That's why we don't need to do any work here because, right, false premises, not a counterexample row. True conclusion, not a counterexample row. Okay, so that's truth table analysis of arguments. And remember, last thing, it's the truth of the premises, not the truth of the sentence letters that matters. When assessing the validity of the argument, we want to know for each situation, if the premises are true, is the conclusion. So it's if the premises are true, not if the component sentence letters are true. We look at all the different combinations of component sentence letters to cover all the situations. And in each one of those situations, we ask about the truth of the premises and the truth of the conclusion. So, if you have questions, please let me know. I hope this helps.